Hello, and welcome back to another video lecture on basic algebra. Today we're going to be talking about standard deviation. The standard deviation is a number used to tell how measurements or data values for a group of data are spread out from the average. For us to better understand this idea though, let's first look at how to calculate it. And then after our calculations, let's look at our standard deviations of sets to kind of understand them. So I have here a list of steps used to find your standard deviation. So step 1, you find the average or the mean of the data set. This is often denoted as x bar. For our second step, we're going to subtract the mean from each data value. So if each data value is x, then we would subtract x minus x bar. The next thing we're going to be doing is squaring that result that we got from this step here. So that gives us x minus x bar squared. We're going to add up all of these squares. So this is a summation of every data value minus the mean, quantity squared, all added up. The next thing we're going to do is we're going to divide that sum by the number of data values, which is usually indicated as n. So that will give us this, the summation of x minus x bar squared divided by n. The last step that we take is we take the positive square root of our result from this step up here, and we end up with this total equation here. Sigma is the symbol that we use for representing standard deviation of a population. So let's look at an example. Here I've got a data set. Numbers are -2, 1, 7, 10, and 22. The first thing that we need to do is calculate the mean. So first, it's going to say, well, n equals 1, 2, 3, 4, 5. So we have 5. X bar is going to be -2 plus 1 plus 7 plus 10 plus 22. And all of this is going to be divided by 5. This gives us the number 7.6. So our mean is actually 7.6. So what we're going to do next is make a simple little table to kind of help us organize our thoughts. So let's go ahead and just make a table. We're going to be listing our x values. We've got -2, we got 1, 7, 10, and 22. And then if we take our next one, it's going to be x minus x bar. So this is going to be -2 minus 7.6. And -2 minus 7.6 is -9.6. So this is -9.6. The next one we're going to do is 1 minus 7.6. So that gives us -6.6. 7 minus 7.6 gives -0.6. 10 minus 7.6 gives us 2.4. And 22 minus 7.6 gives us 14.4. So the next column that we're going to be doing for our little table here is going to be the x minus x bar quantity squared. So that means that in our first case of our first value, we're going to be squaring -9.6. And when we square -9.6, we get 92.16. When you square -6.6, you get 43.56. Squaring -0.6 gives 0.36. Squaring 2.4 gives you 5.76. And squaring 14.4 gives 207.36. So each of these data values are kind of line up across, as you can see. And those are the first steps for calculating your standard deviation. The next thing that we're going to do is we're going to sum up all of these values. So our sum of x minus x bar squared is all of these things added up, and that gives us 349.6. So the next thing that we're going to do is we're going to finish off our calculations. We're going to take this number divided by n, 349.6 divided by n, which is 5, and take the positive square root of that. And when we do this, we get the square root of 69.92, which is approximately 8.3618. And that is our standard deviation for the set of numbers -2, 1, 7, 10, and 22. But this doesn't really mean a whole lot when we don't compare it to something else. So let's look at another set of numbers and compare it to those. Here we have -2, -1, 1, and 2. In this case, n is 4, and our mean is actually going to be 0. And to make sure that you understand where that comes from, -2 plus -1 plus 1 plus 2 all over 4. Well, this top value here, this -2 and this 2 cancels, and this -1 and this 1 cancels, and you end up with just 0 over 4, which is just 0. So when we do these, -2 minus 0, our x bar here, -2 minus 0 is just -2. 1 minus 0, -1 minus 0 is -1. 1 minus 0 is 1. 2 minus 0 is just 2. Then we take those values and we square them. So -2 squared is 4, -1 squared is 1, 1 squared is 1, 2 squared is 4. When we add all of these values up, we get 10. So when we do our standard deviation, we end up taking the square root of 10 over 4, and this equals the square root of 2.5, which is approximately 1.58. Now, if you notice, this value of 1.58 is much smaller for this set than the standard deviation that we got for this set. This set has standard deviation of 8.3618. So if you look at this, this one's spread out fairly far. It goes from -2 to 22. So it has a very high range, about 24 values. Whereas this one goes just from -2 to 2, a very small range. So the standard deviation is much smaller. The next thing we're going to talk about is a data value z-score. So a data value z-score is the number of standard deviations that the value is from the mean. And z is calculated as the data value minus the mean divided by the standard deviation. The larger a z-score, the further the value is from the mean, and the more unusual it is for the data set. So usually a high z-score, often something close to 2 or more, is considered quite unusual for a set. So we're going to look at this set again. We've already calculated our standard deviation and our mean. And we're going to look at the z-score for each value here. So -2 minus 7.6 over 8.3618. Well, this one we've calculated before. This is -9.6. 8.3618. And this equals -1.148. For 1, we get 1 minus 7.6 over 8.3618. This is -6.6 over 8.3618. And this equals -0.789. For our next one, for 7, we get 7 minus 7.6 over 8.3618. This ends up equaling 0.6 negative over 8.3618. And when you calculate this one out, you're going to get a -0.072. For 10, you get 10 minus 7.6 over 8.3618. This equals the 2.4 over 8.3618. And calculating this one, we get 0.287. And for our last one, 22, take 22 minus 7.6, divide that by 8.3618. This equals 14.4 over 8.3618. And when we divide this out, we get 1.722. So when we look at these z-scores, we see that -2 isn't exactly very close to our average, to our mean. So this means that it's -1.48 standard deviations away from the mean, or 1.148 standard deviations below our average. With these, you can see that these are fairly close. 7.6 is very close to our average, our mean, and 10's fairly close to the mean. And then we get 22, which has a fairly close to 2 z-score. It's not quite considered unusual, but it's definitely a little more unusual than the rest of the values. So that's all we're going to be doing today for standard deviation and z-scores for this video. Hope you enjoyed the video and learned something from it, and I'll see you in the next. Goodbye.